Okay, hey everybody, welcome to the second annual Spack user meeting. We're really happy to have this at HPSFCon. And I'm going to kick it off with a little bit of discussion of the state of the project. For new folks, who's new to Spack? Raise your hand. Okay, who's never heard of Spack? Okay, awesome. Okay, for those folks, I have some intro slides in here. Not you, Ryan. So Spack is a tool for distribution of software and for development of software and integration of software on HPC. It's a general purpose package manager. It doesn't have to be for HPC, but it was designed in that world, so a lot of the decisions sort of reflect that philosophy. It automates build and installation of scientific software. The builds are parameterized, and just as a really short crash course for anyone who hasn't heard of Spack, the three things that you want to know about Spack are specs, packages, and concretization. So specs are is the syntax here that we have for customizing package installs. You might recognize that from other package managers as a version specifier. There are other things you can specify on Spack packages, like build options. You can specify the compiler. You can specify what version of a dependency you want to build. And you have a lot of control over that through this syntax. Packages in Spack are basically Python classes. Every package has a definition that looks like this, where you get a Python class. It has some comments that have metadata in them. And then there's what we call directives, which are basically function calls that happen right inside the class body that define what ways you can build this package. So here, this is Kripke. It's an SN transport application. And you can build it with any of three versions. There's two variants there. They have different options that they can take. And then there's an optional dependency on CMake. Or there's an optional dependency on MPI and a dependency on CMake greater than version 3. And so Spack's job is really to pick a configuration from that space, right? It has to pick a version, it has to pick a value for each of the variants, and it has to pick a version for MPI and all of its dependencies as well. And same for CMake. And then once it's done that, it passes a spec, which is basically a description of the whole graph, to these methods at the bottom that go and install the software. And their job is really to translate the spec into installation instructions for CMake or AutoTools or random makefile scripts, whatever the build requires. There's a lot of flexibility in the language, so we can do things like specify what versions of CUDA are compatible with which CUDA architectures, which versions of CUDA offer which CUDA architectures, what compiler do you have to use with which version of CUDA, and we can specify those relationships in packages that you don't really have to write this CUDA package, you can just extend from it in your own package. And same for ROCm, same for other GPU runtimes. So there's a lot of flexibility. Spack has what we call a concretizer. It's our word for a dependency solver. And it basically takes a user spec like this, it turns it into a graph, and it keeps resolving things until it gets a graph with basically all the details filled in. So it's picking values for those variants, it's picking versions from the packages for all the dependencies, and you get essentially a persistent JSON that you can store on disk, and we can query that later and find out what sorts of things are installed. There's a lot of workflows and other things built on top of this. Environments offer all kinds of flexibility that you'll hear about in the meeting, but this is the basics. Specs are how you talk about packages and configurations. Package recipes are basically ways to take a spec and turn it into an installation. So it's the way to build something. And then concretization is the tool that puts them both together and basically chooses a configuration to be installed. Spack is a pretty big project at this point. It has a community. There's the core tool that does all the things I described here. There's about 8,600 package recipes, and there's a huge CI system that I talked a little bit about in the main session. And using all that, and our binaries, people can put together different application stacks that use all these things. And they can be composed of binaries or source or a combination of the two. And I think that's one of the main strong points is that the tool is flexible enough to do that. You can seamlessly combine source and binaries. We wouldn't be able to do this without all our contributors. And so obviously we get lots of contributions from other organizations. The left here is all the places that look at Spack on our documentation site. The right is all the orgs that contribute to Spack, so all of you. And so thanks, because if it was just Livermore where we started, we would just be that little blue strip at the top of the contribution chart, and we wouldn't have nearly as big of an ecosystem, and I don't think we'd be able to sustain this for the HPC ecosystem. So since last year, a lot has happened. We got Spack 1.0 released, and we spent some time formalizing our governance. We talked a little bit about this last year, but I thought I'd talk about the technical steering committee for Spack just because it has so much to do with our transition to HPSF. When we went to HPSF, we had to write down how the Spack project was governed. We had to come up with a governing body. We had to document this. And we tried to be inclusive about it because there are so many stakeholders in Spack. So for the TSC, which is actually, it includes members of the core team, but it also includes external stakeholders on the project who we thought would be really valuable for shaping the direction. And so we came up with a TSC of like 14 people from lots of different organizations, and they've made some pretty important decisions. They were instrumental in deciding that for 1.0, we should include the repository split and the stable package API in that final release. That delayed the release by a couple months, but it also, I think, was the right thing to do for 1.0. And so having this body there to make decisions like that and to push us when we need it has been very helpful. We had some debate over the past year about using a stalebot. You may have seen that got deployed. The TSC voted to do that because they had a hard time tracking like all the issues. Which issues are current, which ones are relevant anymore, which ones have people forgotten about. The stalebot actually does help with that. Some people don't like it because the issue may still be there, but in many cases those issues are so old, like we would never reproduce them. There was really old versions of Spack. And so this is our way of sort of focusing the repo and letting you know through the GitHub interface better what's going on. For release planning, we present all of our release plans to the TSC, get feedback on the features, and we get feedback on problems, like with any of the changes that we make. And so that's been very useful as well. And it's not that the TSC is making every decision in Spack or really telling us what to do. It's when the core team has a question that we think needs a judgment call, and we want a broader audience to do that, then we go and take that to the TSC, and it's sort of the perfect body for doing that. They can decide, how's this going to impact the users? How do we evaluate this trade-off, and what are we willing to accept? And so that's been a very useful aspect of the neutral governance for the project. Spack 1.0 was released last July. You've heard all about this. Greg is going to talk a bit more about the compiler dependencies in his talk tomorrow, so I'm not going to dwell on it, and I've talked a bit about this in the overview talk. But I mean, it was a really big release. We spent a lot of time building up to this, and as I said, the TSC was pretty instrumental in the package API, which I will talk a bit about. For 1.0, we split the package repository out, and Spack is basically it's two things. There's the core tool and there's the packages. They evolved together for most of Spack's life. And with this, we had to rip them out. There was a lot of work around that, but I think it resulted in the tool being better factored. And the community really wanted it so that they could pin a package version and get more stability out of their build. So essentially, now you can clone Spack. It automatically clones the package repo, but you can pin the version to something reproducible. To enable that, we documented this package API, which has been really good. This is the promise we're making to users. We wanted to say, what does 1.0 really mean? Well, this is a big part of it. 1.0 means that we have a set of calls that you can make in packages that we're going to continue to support, and we'll consider it a bug if they break. And so if you upgrade to any 1.x Spack release, we will still support everything that's in the API docs. We've started adding, as we add features that can show up in packages and that can affect the package API, we've started bumping the API version in Spack itself at a commit granularity. So like we've done that twice. On relatively small things. There was a keyword argument added to one directive that really is only used in sort of local repositories. And so we bumped it from 2.2, which is what we released 1.0 with, to 2.3. And then when we introduced a new spec feature in version 1.1, we bumped the package version supported by Spack again because it can support that spec feature. But the Spack packages repo itself, we've actually kept at 2.2. And so we're trying to do this stuff deliberately, and we're documenting in the package API when a feature has to do with a particular version, and so that you know what to expect, and so you know which Spack version can actually use the packages that you have. Our hope is that with this, that most people can just use the most current version of Spack and continue to use old versions of packages, because the current version of Spack should reproduce old packages the same way. And so we're trying to guarantee that, but we also want people to be able to use a version of Spack that supports the claimed version of the package repo. All right. It seems like the transition's gone pretty well. We haven't seen many users having API version problems. We are working on static analysis to check that. And so we think that with TY, the sort of faster type checker from Astral, that we'll be able to test all the packages and guarantee that they're not making calls that adhere to like a too new of a version of the API. And we may bump the API version of the package repo, which means that you would need a newer version of Spack to use it. But like I said, we're striving for very hard backward compatibility. So like upgrading to a new Spack version in the 1.x stream should not be too disruptive. But we haven't done that yet, and the intention is to do it deliberately. So you can see in the package repo, or really in any package repo, even your local ones, what version they're at. And you can bump that if you're using some of the newer features. And I guess with the type checking, we may be able to build a static checker that just tells you like what version of my package is at. Is my version even correct in my package repo? There were some issues, but I think these are just really growing pains. I mean, we split the package repo out sort of as the last thing that we did before 1.0. Getting CI back up and running for Spack packages on the Spack tool itself was a bit of a pain. So we got CI running on the package repo. We had CI running on the Spack tool, but we still want to test every change to the Spack tool against the package repo. And so working out how to do that in a sort of mixed repo environment was a project for after 1.0, and we've finally gotten that done. We came up with this testing strategy. Spack develop is actually tested with latest Spack packages all the time. That's so that we just don't break anything in develop that won't work with the latest packages. Spack packages developed, though, runs with a pin Spack version, and we just deliberately update that over time. And that's for stability in the package repo. We really don't want we don't want package developers debugging issues with core, and we don't really want core people debugging issues with packages. So the strategy is really designed to help with that. And Spack package releases, we run those with the latest Spack package version before the release. We're working out how we might do occasional really old version testing so that we guarantee that, that the oldest possible version of Spack can run and build a particular version of Spack packages yet, but we haven't really gotten a cadence for that at the moment. All right, Spack version 1.1 was released in November. I'm going to go into some of these features. One of the things that happened after the 1.0 release that I think that people noticed early on was that we had a lot of flexibility around compilers, but it didn't always do exactly what people wanted. It was in some ways too flexible. So in 1.1, we added a bunch of features to give users more control over how the compilers are resolved and to give them more constraints that they could apply to compilers. We've also done a bunch of improvements to config, to fetching, and there's a new installer that I'll talk about a little bit, but I'm mostly going to give shout outs to other people's talks where it's relevant. So compiler unmixing. In 1.0, the concretizer is free to make a decision to make the C compiler of a package different from the C compiler for its dependency. And note that this is just within languages. It can also make the Fortran compiler different from the C compiler, but people don't seem to mind that as much. Compiler unmixing is a way for your project to say, I don't ever want that. And so basically pick one C compiler, one C++ compiler, and one Fortran compiler for the whole graph and don't mix them. If they have dependency relationships, do not build some other package with a different compiler. And so you can add this. It does mean that in certain cases, like where the Intel compiler depends on GCC or things like that, that you may have difficulty resolving some graphs. But for a lot of graphs, this is a very simple way to increase the concretization speed and also to rule out some of the cases that people typically don't want. So a lot of teams have started just going with compiler unmixing. If you need more control than that, there is propagated compiler preferences. So you can actually specify that a particular subdag in your graph, so basically everything under a particular package, should use a particular compiler using %%. And that basically just says propagate the compiler to this whole subgraph. And you can do a lot of fairly complicated things with that. Another advantage of this is that you can specify exceptions. And so what that means is that, so for call path down there, you can say that that gets C equals GCC, but other things in this graph are going to get the mixed sort of Clang G4tran, the LLVM build. Sorry. There is also, you can also specify exceptions for compiler unmixing. So if you use this instead, you can specify in config that particular compilers ought to be accepted from this rule, or particular packages should be accepted from this rule. So anyway, you have a lot of control. Another big thing in 1.1, and this is sort of a build up to some features that we're planning to ship in 1.2, is people have complained since the dawn of Spack about how we structure configuration and about where the different configuration files go. And probably the biggest pain point for some users is that we store configuration in ~/.spack. And so what that means is that like when you start Spack on a particular machine, if you have some old config there, or if you have some config from some prior run or something that you did, it can affect the build that you're doing now. And that's not great for reproducibility. It is good for like persistent configuration options. Like if you want to use the new installer all the time, that's a fine thing to put in your ~/.spack config. But if you have package preferences in there or compilers or things like that, they can affect later builds. We're trying to rework the configuration so that it's customizable. And so essentially we added this new include configuration scope. And what that means is that most configuration in Spack is coming from configuration, which is a bit of like one of these impossible cubes in terms of like thinking about how exactly that works. But it works pretty well. If you clone Spack and you look at the include.yaml that comes with it, the scope in etc Spack within the Spack installation is basically the one that controls everything. And it includes all the other scopes there. And so you've got that scope at highest precedence. You have a bunch of other scopes like ~/.spack and so on that it includes. And if you want to, if you own the Spack instance, you can just remove them. And so you could override this. You can also, in an environment, put include : and override the other scopes that way as well. So it works just like the rest of config, where you can override things. So this is going to help us in the future because it enables us to really isolate an instance of Spack. I think with all of this configuration expressed as configuration and not as Python code, we won't have users building wrappers around Spack that like patch out the config lines or things like that, which we've had in the past. And we are planning to add a command in 1.2 called Spack isolate that will basically allow you to very quickly just reduce Spack to like a self-contained thing. And I think a lot of CI users will use that. People who like to just control one Spack instance will use that. But other users who want some more sophisticated configuration and rely on it can do fancier things too. I guess the other thing that you can do with this is if you, at your site, want to offer users yet another way to configure Spack, then you can put that in here. And I know that there's some sites like Fermilab and places where that's of interest, where they would like to put ways for users to customize things that are not in the standard locations, but are also maybe not in the home directory. So you can get a lot of granularity out of this. You can include remote configuration from Git now, which is pretty cool. So if you, and this is also a precursor to a feature in 1.2, basically we made it so that you can say, go fetch a config file from a location. And in this case, we've got the Git repo up there. We've got a couple paths inside of it that contain config files. And these are just pushed on the config stack inside of Spack. And it will go and fetch this when it encounters it, when it's reading the config. This is a lead up to including entire environments, which I think is going to simplify the process. Right now, because you have to specify the files, it can get a little tedious. But in 1.2, we're going to have a feature where we can actually include whole environments. I think that will make it very easy for people to put a Spack environment on GitHub with, say, the standard configuration for a particular use case, for a particular machine, and for a particular site, and things like that. And you can basically just start your environment with include that thing and build on top of it very easily. So that's the goal with this. And this is the precursor. This is just one file. You would have to configure. You'd have to include all the files individually. We want the whole environment brought down. All right. So you may have seen who's used the new installer? Who's tried it out? Okay, if you haven't, then you really should try it because it's pretty robust. And you can use it with this command at the bottom of the screen. And Harmon's going to give a demo of this in his talk, I guess later on today, like at 10:45. But it's very cool. It shows all the concurrent packages that are building. It makes concurrent builds the default. Concurrent builds is something that we added in 1.0, thanks to Kathleen back there. And we didn't make it default because the output was still interleaved, and so it looks a little ugly by default. With 1.2, we're going to have the new installer as the default. You can try it out now. But you can see all the different builds. There's fancy terminal keys that you can press to tail different logs over time. So you can say, like, show me the output of that thing that's building or that thing that's building. And it shows the things that completed up at the top and sort of gradually moves down. So it's friendly for, like, CI logs. The version that's going to go into 1.2 actually has special support for that, but I'll let Harmon talk about that. In 1.1, it was not yet feature complete. It is now almost feature complete, and it supports builds across nodes. And so you can actually use this to build across your cluster. So every node would be doing parallel builds, and the nodes would be coordinating with each other to share the builds across nodes as well. And then there's job server stuff in here too that Harmon will talk about in his talk, but that's even more dynamic parallelism among the package builds that are being done. So people should see some really big speed ups, I think, for large stacks using this stuff. All right. I don't normally put patch releases in these project updates, but I thought 1.1.1 was worth talking about. It does support Python 3.14, that's fine. It has a lot of better error message support that people were wanting. And we've been on sort of a vendetta to speed up the concretizer in Spack. And so there have been lots and lots of optimizations that have gone in, some bigger than others. These are probably the two biggest ones. These ones got backported to 1.1.1 because we thought they were so impactful. Basically, if you try this, the solver is probably up to twice as fast in 1.1.1 than it was before. And so we're really trying to speed up the latency of solves. All right, and I'll do some roadmap stuff. So for 1.2, I've talked about a few of these, but you saw the config change. That was a precursor to a lot of these configuration fixes that we're going to do in 1.2. Some of them have been asked for a long time. In 1.2, Spack's going to be XGG compliant. And what that means is if you do a fresh clone of Spack, it's going to put stuff in the XGG standard location. So who knows what XGG is? It's a desktop standard. It says like it's to keep your home directory clean. It's to have standard places for things like caches, so that maybe people can configure it at machine granularity, that the caches go on a particular temporary volume and other things go in a good place. People have wanted that standard for a while, and so we thought it was worth doing. We will still respect the old locations if they exist, and so it's not going to be disruptive. It's not going to just change everything under your feet. If you are using, say, the old install location, and we notice it, then we will continue to respect that, even with the XGG stuff. Well, unless you set the XGG variables explicitly. So we're not changing the defaults under you. It should be smooth, but you can go and configure Spack to use these new locations, and it should be good. With that, we're also trying to do, we're trying to make Spack easier to share so that you could have a central Spack, module load Spack, and have users install things by default, say, in their home directory. The transition to XGG puts a lot of the default locations in the home directory, which is what other tools do in a standard Unix environment. And yeah, I think that's good, because like if we go and pip install Spack, which is the other thing that we want to do here, or if a site deploys Spack, then you can have a site deployed instance with an upstream maybe in it. And then a user can install stuff that uses the site-provided things by default. And then likewise with pip, you can install sort of a read-only Spack somewhere in your Python installation, and then you could use it to install things in your home directory. So it's separated the way that you would expect. That doesn't mean, and this is the interesting part, that we can't have an isolated Spack. And so with the customizability of config, we're trying to satisfy the people who have CI workflows who just clone Spack and do something with it right there, where they want all the config to sort of live inside the Spack directory and then to just blow it away when they're done. So all of this also enables us to add an isolate command that would let someone do that in one step. So basically, if you want to do it in say, CI mode, you clone Spack, say Spack isolate, and then you have sort of a self-contained Spack instance. So we're trying to satisfy everybody. It's been very hard with this particular set of features because they change so much about sort of people's default expectations. But we're looking forward to having this stuff in 1.2. Kathleen is going to talk more about SBOMs and security provenance later. There's a whole talk on that. So stay tuned for that. But that's something that we're going to ship in 1.2, where every package is generating SBOMs. So you can go and scan them. You can keep track of whether there are CVEs for particular packages. And we're planning to continue to improve the security stuff over time. We have some new funding for security-related work in Spack, and I think that's going to help in this area. More performance, we're going to continue doing that. There's actually a PR that's going to go into 1.2 to cache environment activations and loads basically at install time. So those should no longer have to run a bunch of Python code and spider your dependency graph and all that. It should be like loading a module from a shell script, so it should be really fast. It'll just be a source. And that means that if you change your package file, the load for an installed package isn't going to change. So it's basically, it's fixed at install time because we cache it. But I think that's actually good. We'll have an option so that you can go and regenerate it from the current package file, but we're trying to make the behavior of the installations and therefore of the binary packages a bit more consistent over time. And that's going to later enable us to make the binaries completely independent of the package files, which they're currently not. There's a bunch of activation code in the package.pys. And what we would like is to have the binaries be fully installable by themselves. and just usable without even thinking about like package repos or building or concretization or any of those parts of Spack. It could function as a pure binary package manager. So we're on the way to that. Greg will call me out and tell me that this PR is not sufficient for that, but it does get us a little way. It gets us pretty far along the way. Including environments, I already talked about that, but I'm very excited about that. I think that's going to enable people to share and compose Spack config way easier. I think we're already using it in CI to do more, to better organize all the YAML files that we use to configure our builds. And so I think that's going to help folks with their own environments and to reduce the complexity. Build cache views, Ryan's going to talk about, but essentially what that means is you can have a binary cache expose different views with different subsets of binaries. So if you have a cache that has maybe like some Rockham builds in it, and you have a cache that has some Intel, the same cache has some Intel builds in it, you could expose both of them as sort of separate views of the same cache without copying them to different places, either in S3 or on the local file system. So that's a nice way to organize things and to give users like concrete URLs that they can add mirrors for, so that they can just reuse stuff from, say, the platform stack or the use case stack that they're pulling from. New installers in Harmon's talk, so stay tuned for that. And then there's a new feature that's already in develop for 1.2 that we added to environments to simplify a bunch of use cases that I wanted to talk about here. Concretization spec groups is, this may seem kind of complicated, but we've had use cases in Spack where people will sort of chain environments, or they'll like try to build, say, the compiler or a set of dependencies for a stack first and then fix it, and then build everything else with, say, those compilers or those dependencies. And we've also had use cases that are stateful, like our tutorial cache. So we maintain a build cache for all the binaries that we use in tutorials. And it's really supposed to model what a user would do on the command line if they type a bunch of commands in order, and that's stateful. And we didn't have a way to express that in environments, and we started hitting the limitations of that in CI, where it was just getting to be more of a pain to reproduce exactly what was in the tutorial image. So what this feature does is it lets you basically specify a partial order of builds in your config. So in the example over there, you can see that there's a compiler group where you build GCC, and then there's two groups beyond that have different microarchitectures. So one's for x86 64 v4, one's for x86 64 v3. It's basically saying take the compiler, use it for both of those two other groups to build them, and then you've got a definition at the top that says like build the same set of apps in both of those groups. So it's very easy to express stuff like this, where before this would have taken a couple different environments to do. And Spack's going to go and build the compiler first, and then build the two things that depend on it sort of separately in their own concretizations. And this enables us to express basically stateful series of concretizations with potentially like reusing packages and things like that. It enables us to exactly reproduce our tutorial pipeline. And I think this will simplify both our build cache curation. As we're trying to make the build cache more compatible, we're going to have like a base set of builds that provide like basic dev tools. And then we want to force all the combinatorial builds to use exactly that. And so we can express that with a syntax like this in environments. So this is a major improvement. This went in a couple weeks ago, so try it out. It's really simplified some of the workflows that where people would like make an environment and set things as externals in another place, and you don't have to wire all that up anymore. All right. And then I put some really long-term things on the roadmap just to talk about. We're going to try to do more build reproducibility post 1.2. We're really trying to go through the internals of Spack and draw lines between the different parts of the pipeline. We want, say, concretization to just depend on packages. We want the build to just depend on packages copied into, say, an archive or something like that from the concretization stage, so that it's completely separate from all of your local config, all the things that you used to set up that concretization. And then we want the installations, like I said, to be completely independent of that, so that you could use them as just pure binary packages. And so with that, we're going to try to make basically an archive format that lets you do reproducibility for a build, even if you've thrown out the package repo, or even if the prior package repo has gone away. We currently store that information in the package installation directory, but we don't really have like a turnkey way to go and use it and to reproduce an exact build as we did before. And so this will enable that. That's the goal. Foreign packages is something that we've thought a lot about. A lot of the burden of maintaining the built-in, or the now separate but still called built-in Spack packages repository is tracking ecosystems like Python or R or JavaScript or things like that. And we can model a lot of the semantics of other package ecosystems with the features that we added for 1.0. With the ability to do duplicate build dependencies, with the ability to, with the version syntax that we have right now, there's a lot of capability in there. And we think we can write adapters for, say, PyPI, for Rust, for JavaScript, so that we can make that integration more smooth and you don't have to wait for somebody to write, say, a Spack package for those things. We could generate them automatically. So we're working towards that. Greg and Alec have been thinking a lot about what this ought to look like. Right now, the model that we're thinking about is that we would basically look at the metadata for the other ecosystem and bring it into Spack some way and unify the solve. We don't really see a good way to do this where we rely on the solver from another package manager because there's just too many constraints that might pass between the two. But we're still thinking about it. So I think that's a really important thing for sustainability, especially as so many things start to depend on Rust. Like even in the Python ecosystem, there's Rust at the bottom of it, and we need a good way to have a stable dependency on cargo stuff and to make that reproducible. Split metadata. So we were thinking about split debug info, and we're also thinking about throwing more static analysis into Spack and CI. We have some folks who want us to really generate serif so that they can scan it offline and do interesting security checks and things like that. So you may see that pop up. And then Greg is going to talk about cross-compilation in his talk. It may seem kind of niche, but it's fundamental to the model of compilers in Spack. And really what that's going to involve is separating, say, the run and the build environment conceptually inside the solver. And that's something we've needed to do for a long time. I think it will maybe not impact most users directly, but it will really improve the Spack infrastructure. And the Recon folks really want it because for some reason they set up a machine that has ARM compute nodes, but x86 64 compile nodes. And so we're going to try to make that less painful for them because currently they have to build on the compute nodes and they're quite slow. So we want to fix that. And then finally, just for really long-term stuff, compiler bootstrapping in the solver is something that I think we will eventually need. If we want to really model GCC, we need to know that it was built with GCC. And so that the solver is pretty close to being able to resolve that. To do that in a performant way is really the thing that we need to tackle there. And then finally, libc plus SpackOS. If we have the compiler bootstrapping thing, we can do this sort of libc bootstrap dance. In the solver can actually plan those kinds of builds, and we could ship a container image. This is something that people have done already in like a staged build. They built the glibc and the compiler in one environment, and then they went and used it in another, and then built a container that contained nothing but Spack stuff. So it's not like we're too far away from that, but making it work like everything else in Spack, where it can be conditional and substitutable and modular, is really what we want to do there, so that you can just say caret muscle and build a whole stack with muscle in it. So that's the goal. And that's it. That's the roadmap. And yeah, I'll take questions. Evan has a question. Greg's running around.
Nice. Okay, a couple comments. Cross-compile, I think, is actually really important for CI as well.
Yes, that's true.
And I think that opens the door to get off of a fully self-managed infrastructure for doing the CI. Mm-hmm. Take advantage of the standard runners that are available in GitHub or wherever else.
Yeah, that's a good point.
Second, the spec groups. Can we include those? Could we have those in includes, the repos that we would include?
You can.
Yeah.
It's a little mind-bending because they each have their own config scope, but like yes, you can.
Okay. Now on the includes, can they be private repos?
Can they be private repos? What do you mean, like?
Like a private Git repo.
Yeah, as long as you have.
As long as you've got your SSH keys to.
Yeah.
Grab it.
Yeah. Okay. So that raises a topic that's a sore point for me, and that's private repos in CI.
You want credentials somehow?
Yes.
For the, yeah. Okay. I mean, yes. Okay.
Yeah.
It seems like a thing that we could add fairly easily. Let's talk about it and how to do it and get it scoped out.
And then the other thing about the include, I'm curious how that interplays with upstreams.
You could have an upstream in your included environment. So if you want the settings for a particular machine to automatically use the upstream that's deployed on that machine, you could stick that in the environment config and it gets included just
So
like any other config, right?
Todd and I just started talking yesterday about how you could have an environment that seamlessly toggles between building to a path and then when it's included, using that path as an upstream for whatever comes next. But we don't have any actual technical details on how we would do that yet.
Yeah. But you could, this is the usual Spack bottom up build. So
Yeah, so I'll have a +1 for the private repos. I need some credentials to clone from a GitLab instance where I just have a CI token. And
Yep.
and the other thing I would need is when you do a git clone of some configuration files, you have to control when you do the git clone. You can't do it on the compute nodes because they don't have network. So it has to happen at a particular time. You have to be able to control, this is going to concretize at this point in time, get everything, and then
that one we did think of. So like with the remote includes, the separation of the different phases in Spack includes like a fetch stage. And we want to include like all of these remote includes and environments in the fetching stage. So, so if you do a fetch, you should be grabbing all the config you need for the later build.
Just a quick one. I'm glad to see that you can use Git now instead of doing an include by URL.
Yes.
Because that involves the checksum. And if you're pulling off a branch and the commit changes, the checksum changes. So it makes maintaining the includes a little trickier.
You can specify the commit on your.
Yeah, you can specify
probably
the.
should, but yeah.
Yeah, but we're doing
It's up
it,
to you.
a pull from GitHub
Yep.
URL to do that.
All right, one more question, and then we'll move to our next talk.
All right. I just have a question about with the package API being stable.
Yep.
Does that imply that when I upgrade versions of Spack, that my hashes will be consistent between Spack versions, or is there a risk that?
If you pin the packages, your hashes should be mostly stable, modulo some non-deterministic things in the. Well, I mean, I guess if we change the defaults in the concretizer, they may not be stable between Spack versions. So no, it doesn't imply that.
Okay. Thank you.
But if you use you should use a lock file if you want that.
Yep.
But the lock file will be compatible with the future Spack version.
Also, Spack versions could change the hashing logic itself.
Yeah, that's true.
We have not had to do that in a while, but we think we might need to do it soon.
The provenance that we add for SBOM is likely to change the hashing, and so like that means that new builds or fresh concretizations will probably generate a new hash.